So today we're going to learn about probability and set theory. There's a lot going on in this lesson, a lot of definitions, a lot of new symbols you are going to see. Please write all of your notes. We're going to do a couple practice problems, and we will make sure to practice more before the regions. What is probability? Probability means possibility. It's a branch of mathematics that deals with the occurrence of a random event. Normally, it's expressed from 0 to 1, which pretty much means 0% to 100%. And it means the extent to which something is likely to happen. Now, we're going to be talking something about sets, and it's an important tool in the study of probability as well as future mathematics. Need to understand the definitions, terminologies as symbols associated with set theory. Okay, so before I get to the next symbol, I'm going to give you an example of what set theory is. Okay, so from algebra 1, when you learned about rational and irrational numbers, they are all sets of the number real numbers because both of them are real numbers. So they are sets. So it's like kind of like a part of something. So here are some new symbols that we're going to be learning about. So please write the English meaning of. The E off the side means an element of. So an example is the number 1 is an element of whole numbers because 1 is a whole number. The U means union, and that means or. And then the uppercase intersection means and. That sideways symbol with a line means subset. And then complement, we learned about the way the events might not happen, or the chance that it will not happen is called complement. And then if there's no chance or there's no number possibility, those two symbol means the null set, or we call it the empty set. So let's fill in this table. So set notation. If A is a subset of B, or if A is an element of B, I want you to think of the Venn diagram. The circle in green is subset B, and A is part of that. Just like we gave in the example, 1 is part of whole numbers. So the English meaning subset, A is a subset of B, and all the elements in A are also in B. A union B means the union of two sets is the set of elements in either A or B or in both. So if you notice, you have a set of A in purple and you set of B in red, and it comprises of everything, both of them. And same thing below, a union of two sets is a set of elements in either A or B. Same thing, you have a set A in orange, a set B in that teal color, and it's either or. Okay. So A intersection or A and B means the intersection of two sets is the set of elements that are in both sets A and B. So right here, if we notice, I'm going to zoom in. A and B is this little area right in the middle. Okay, it has to be both. It has to be both. And then complement is a set of elements that are not in the universal set, but are that are in the universal set, but not in the given set. So you have set A over here in white, and it's everything else that's not involved in that set. Now we're going to go over some definitions dealing with these sets. So complement is the probability that the event does not happen. And you get that by 1 minus the probability. So an example is the probability that Mr. Knox gets 100 on an earth science test probably is like 2%. But the complement of that, there's a 98% chance I won't get 100 on an earth science test. Mutually exclusive events are two events that have no outcome in common. For mutually exclusive events, it pretty much means the probability of A and B is 0. It can't happen. So that's what mutually exclusive events mean. Next are independent events. Independent events are two events are independent if the outcome of one event does not change the probability of the other event. So if they are independent, the probability, the two events are independent if one event does not change the probability of the other. And there are formulas proving two events are independent. The probability of A and B would be the probability of A times the probability of A. And then the probability of A equals the probability of A given B, which we'll talk about in a second. Dependent events, the outcome of one event impacts the probability of other events. So the formula proving two events are dependent are the probability of A and B is the probability of A times the probability of B given A. And again, we'll talk about B given A, this line in the middle, in a second. So conditional probability is what you've seen in that line. The probability of A given B, this line between A and B here represents A given B. It means the probability of event A occurring after event B. The formula for conditional probability is probability of B given A is the probability of A and B over the probability of B, or the probability of A given B over B. So let's go over some regions problems and the way they use this on the regions. On a given day, the probability that Nick oversleeps is 48%. So probability that Nick oversleeps, and I'm just going to put oversleeps, is 0.48. I like to change it into decimals. So remember, 48% divided by 100 equals 0.48. The probability that Nick will have a quiz is 25% or 0.25. Assume these events are independent. What is the probability that Nick oversleeps and has a pop quiz on the same day? So the probability that Nick oversleeps and has a quiz is 0.48 times 0.25 using our formula. And this equals 0.12 or 12%. So the answer here is D. So the answer here is D. Sorry, I was highlighting that picture. All right. Zoom this in a little bit. A fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D, that a customer uses the drive-thru, and F, that the customer order French fries, are independent. The following data is given in a report. The report is that the probability of French fries is 0.8, and the probability of French fries and drive-through is 0.456. Given this information, what is the probability of F given D? So it says in the problem that the events are independent. So where is it? Are independent here. So therefore, I'm going to use the formula probability of A equals the probability of A given B from our slides. So therefore, just from here, the probability of F given B equals the probability of F, which they give you. So the answer is 0.8. That's simple. You just had to know the definition of independent. And now we are on our last one, which we're going to be looking at a table here. The results of a survey of the student body at Central High School about television viewing preferences are shown below. Are the events student is a male and students prefer reality series independent of each other? Justify your reasoning. So what I'm going to do is I'm going to say the probability that students are male, let me write this below it so we know probability of students are male and probability of reality TV. So let's do the first one. We know for them to be independent, the probability of reality TV and male is the probability of reality TV times the probability of male. So now let's do each one. And on the side in green, I'm going to show you how I got that. So the probability that students prefer reality series and male is going to be right here, 70, because it's both reality series and males. So therefore, it's 70 over the total, which is 490. That's how I get that probability. 70 over the total, which is 490. Now, what is the probability of reality series? So the probability of reality series, which includes male and female, is 180, and the total is 490. Lastly, the probability that they are male is the total males, which is 230, divided by the total people, which is 490. And now I'm just going to do some calculations, and then I'm going to get my final answer, and I'm going to be able to prove or disprove it. So the probability that reality TVs and male is 70 over 490 equals 180 over 490 times 230 over 490. So let's see if these are equal using a calculator. This simplifies to 1/7. And when I multiply these two probabilities, when you multiply across the numerator, you get 41,400 over 240,100. Now, 1/7, if I would simplify this, does not equal, I'm going to simplify the other fraction to 414 over 2,401. They do not equal each other. So I'm going to put a little statement here. No, they are not independent. Because P of R and M does not equal P of R times P of M. All right, you have about 8 practice problems, I believe, to do for the rest of this packet.